This video will be about mutually recursive types. In the last video, we talked about just recursive types, and they were types that were self-referencing in some way. So we made the example of a recursive list that had elements of the list that were of type list themselves. So please check that video out if you haven't seen it. But today, we're going to look at mutually recursive types. So a mutually recursive or two mutually recursive types are types that refer to each other in their definitions. So it's like a circular relationship between the two. To illustrate both what this looks like and how we implement it, let me show you an example. So I'm going to define a type for a person right now, like this. And it's going to be a record type. So we would give it some attributes here. We're going to say, first of all, that it has a name. This will be a string. Second attribute we would give it is age. That will be an integer. Last attribute we'll give it is children. If I can spell. There we go. Children, and that will be a list of child. So child, which we haven't defined yet, and then a list like that. Okay? So now we need to define a child type, and you might think that, okay, since we're referring to it here, we need to define it actually above this type. So we could start doing that and see where we end up. So type child. If I write this and then I say this would be a child of person. So what we're saying here is this is a discriminated union. Like technically you could have multiple options here, but we're just providing one. We're saying that the child will be referenced as child or will be called child, and the type it will be implemented as is a person. But the problem now is, person comes here. So we can't refer to it right now. Optimally, we would want to have this below, but then the reference for child will not work. So the question is, how do you actually define a relationship like this where you have mutually dependent types? And the answer to that question is you have this AND keyword in the type definition, which makes these types, which lets you define the types in an appropriate way so that F# knows what you're trying to do. If you write AND here instead of type, you can see, and this one needs to be after the original type declaration of person, then you can see that this now works and we can actually compile it. So let me construct an example using this, and then we can see that this actually works. So let me create first, let me actually make this mutable. That's going to make our example a bit more interesting, like that. So I'm going to create a few people. I'm going to say Alice is going to be a record, and then I would say name equal to Alice. I'm going to fast forward through this part so that you don't have to watch through everything. Okay, so I created my 3 records here, and you can see that they're called Alice, Bob, and Charlie. They have ages 30, 32, and 8, and none of them have children as it is right now. Now, the reason I made this attribute mutable here is because we can change this now. If it wasn't mutable, we wouldn't be able to assign new values to the children, and in most F# programming, like in proper functional programming, you would probably not have this mutable. Whenever we can, we want to prevent from creating mutable records, but nevertheless, I wanted to be able to create these 3 before I actually update the children of either one. So let me just say that then Alice dot children, this we would set to be child Charlie. So this is how you would actually put a record in the list. You can't just give Charlie directly because Charlie is now a person. You need to use the constructor of the child and say, constructor of the child and say that this is a child using Charlie as the implementation. So we can do the same thing for Bob if we want. We can say that Bob has, let's see, Bob has children as well. And for this one, we'll just give another list. So we'll say child, and in this case, we'll just give Charlie as well. Okay, so Alice and Bob, they mutually have Charlie as their kid. Okay, and that's it. So that's how you can use actually types that refer to each other in their definition without having compilation issues in F#.